Hello, this is Mrs. Ross, and this is the Generator Phet Lab. This is going to take the place of our Energy and Forces portfolio since we have a snow/distance learning day. So I wanted to kind of go through this with you really quickly. I'm going to be marking up this Word copy, but I wanted to show you the PDF copy. If you're looking at the PDF copy, you can see all of the different, what are they called? Variables, which are all right here. If you're looking at the Word copy, it kind of it does something weird right here. So we'll see how it goes. But it has this introduction about the Hoover Dam. If ever you get a chance to go see the Hoover Dam and go on the tour, I highly, highly suggest you do it. I was actually more impressed by the Hoover Dam than I was the Grand Canyon, but maybe that's just because I'm a nerd. Highly suggest. It is a feat of engineering, absolutely. So we're going to scroll down, and part one, we go to Phet. So let me go to, let's see, I thought I had it open, but I do not. Let's see. So we're going to search for Phet, and that's it. And I searched for generator. And then, oh, okay, so we'll click on generator. And we'll click on the play. I also clicked on this run chirp j browser blah blah blah. I thought it said cheap the first time I did this, so. I'm trying to drink my Slurpee. I'm so sorry. I got a Slurpee. Anyway. All right, so let's go back to what we have here. It says, begin with the bar magnet, click see inside and observe the magnetic domains in the magnet in the fields. The field that the domains create, draw a diagram of the bar magnet in the space below. So let's go back. We're going to click on bar magnet up here. And this is what we see. It says see inside the magnet. So you're going to draw just a small portion of this in the space that you're given here. And then it says move the compass around the magnet. What happens as the compass moves? So what you do to move the compass is you kind of click on it and you just drag it around. And you can see that the needle changes. What I would do is I would take it from where it is at the beginning, and we can see that the red needle points in the direction of north. So let's go here and see if it still points in the direction of north. It does not. It flips. And then here, it points in the direction of north. And then here it flips. So you can write that down on your paper. And then part two is in the pickup coil. So if we go back, the pickup coil is the next tab. And it says what happens when a magnet is moving through the coil, and you can do that in the simulation. So this moves, you grab the magnet, you click on it, and you move it through, and you can see what happens when you move it through. And you'll write that next to it. There's not a whole lot of room. Investigate the brightness of the light or the current. So the brightness of the light is directly a result of the current. As the number of loops is changed, the speed of the magnet changes, and the area of the wire coil is changed, and the polarity. So let me write those down. So what I did on my paper version was I said, okay, I need to mess with the number of loops. Well, you can, let's undo both of those. So this would be number of loops. This area of coil, speed of magnet, and polarity. And let me show you where you can find all of that. So if we go back, we flip the polarity here. And what I did after each one was I clicked reset all and yes, so it'll start over again. You change the loops here. I think it just goes up to 3 and down to 1. So you can change the loops there. Again, I clicked reset all and yes. And then you can change the loop area here. And then as far as the speed of the magnet, I controlled that with my mouse. I was like, well, that's fast and that's fast and this is slow, you know. So you should be able to answer those questions. And then part 3, we're going to be clicking on the next tab, which is creating a magnetic field. So let's go back. Electromagnet. So this is what we have. It says just like the changing magnetic field from a magnet to, why can't, anyway, it doesn't matter. Cause electrons moving. Investigate how the properties of the electromagnet affect the magnetic field. So these are the properties that I looked at. I mean, you could use different ones, I'd guess, but the number of loops, changing AC to DC, and I'll show you how to do that. Voltage on the battery, and then the compass. So let me go show you those. So, okay. So the loops, you can change the loops here up and down to 1 and up to 4. Okay. And we're looking at how it affects the magnetic field. So you can see that by the brightness or the dimness of the magnetic field. So reset, yes. And then AC to DC. So right now we're at DC, we'll go to AC. AC is alternating current, so it's obvious what's kind of happening here. It's going on and off, on and off. Okay. And then I said voltage. If you click on this and move it, right, great. Okay, let's try this again. We click on this and move it, and we change the polarity, actually. So it looks like we can go up to 10 volts on this side, and we can go up to 10 volts on this side. So the voltage could also be a change in polarity if you wanted to do that. So you could do /change in polarity, or that could be your fourth one. It doesn't matter. We just kind of want to get some observations, and then let's see what happens to our little this as we run it around. Does it do the same thing it did with the magnet? And that would be our last one. So, and your results are basically just what you observe. What do you see? What do you not see? Well, don't tell me what you don't see, because that's not helpful. They're observations. So part 4, it says more than meets the eye transformer. In a transformer, moving electrons of one coil create a magnetic field. And then it talks about step-down transformers. So the power plant, Encore Power, has to step that power down to go into your house, or it would blow all of your circuits when it goes from high voltage to low. So let's see. Let's click on transformer. Okay. And it says investigate how the properties of the transformer's secondary coil affect the current in the secondary coil. So let's see. Secondary coil. What in the world is that? The primary coil has 4 loops, and the secondary coil has 1 to 3. So let's go back. So that means that this one, I don't know if you can see my, let's go back. So primary coil has 4. So the primary coil is the one that's attached to the battery. The secondary coil is attached to the light. That's the best way to put it. So we're going to change things about the secondary coil and see what happens to the light. So let's see what our options are. It said number of loops again, and loop area. Let's go back. So basically you're going to be running this through here, and you can change the number of loops to 3 or down to 1, and then you can change the loop area smaller. I don't know, how would it go through there? Oh, okay, that's funny. It does, but it doesn't. Okay. That's really the 2 you can do there. And then I would love to mess with the voltage on the primary. So voltage on the primary, let me write that down. Volt on the primary. Okay, and then the polarity, because if you take it all the way one way or the other way, it's going to change the polarity. So, cool. Move the primary coil in and out. What happens? Oh, and then change it to AC. That's cool. So fun. And then what happens if we bring this in? It just kind of, okay. With the DC primary coil, move the slider back and forth. What happened? We kind of did that up here, but you could answer that. And then the last part that covers what we have here is, it says the Colorado River runs through it, or generator. So let's click on the generator. And this is kind of a very, very simplified sketch of what happens with the Hoover Dam, right? So it says click on show field and observe the moving magnetic field. And then we're going to mess with some things, obvi. So show field, cool. And then I'm going to open up the water here. So we can see that the more water that's going, the more RPM our magnet is turning, the brighter our light. When there's just a little bit of water, it's only turning at less RPMs or revolutions per minute. Our light is not as bright. So what did I put for this one? So I put here, so we're going to be changing the water or RPM, the number of loops, the loop area, and then what else can we mess with? Loop area, that's really just about it. So, and I think that's all we need. And then there's a summary here that talks about Lenz's law. I'm not exactly sure if you guys covered Lenz's law yet. And then it talks about the terms of conservation of energy. That should be something that you're familiar with. Draw a flow chart. This flow chart, it would just basically should be like that the water and then the magnet and then whatever else you see here. Like this is the flow chart here of what should be done. Faraday's law, where it asks what these are, your best bet is to look that up. So let's see how easy that is. So Faraday's law. Awesome. So this explains all of it right here. Or you should be able to find one that explains any of these. So that should be fine. And it talks about step-down transformers. And then it has conclusions and calculations. See what you can do with that one. And if you have any questions, please let me know. I'm going to go ahead and let you guys go. And again, feel free to email me with questions.